Hi people, welcome back to the next lesson on method of sections. There's the question that says determine members HJ, CJ and CD using method of sections. If you notice there, HJ, CJ, CD is in the line. So if I ask a question, most probably they will all be in the line. Okay, I will not ask you find that one using method of sections because that won't make much sense. Right. And if I give you a question like this, now those of you who've done applied mechanics last semester, and if you've done all the work I asked you to, you'll see this is going to ring a bell. Okay. So the first part of this question would be determine the support reactions. VB is 31.67 kilonewtons, VE 73.33. There's a pin joint, and notice there's no HB there. Why? Why don't we have HB? Or what's HB equal to? HB is equal to 0 because there's no horizontal forces acting. So there's no horizontal reaction. Okay, so there's just two possible reactions here. Right, I'm going to draw my cut line through the unknown members. I'm going to do that over there like so. And I'm going to draw it like say so. Okay. Yep. Right. So what's the procedure? I'm referring to the procedure again. There's the procedure. Okay, which if you get stuck. So for every joint, for every member I'm going to solve, this is the procedure you go through. Okay. Right. So what's the first part of the procedure? All right. I'm going to assume HJ, CJ, and CD to be tension or compression. Right. I am going to assume that HJ is in compression, so I'm going to do that. And I'm going to assume CD to be in tension. Now notice there, I'm drawing my arrows in on the one side or on the right side of the cut line only, because I'm going to consider forces to the right side only, so I don't confuse myself. Don't assume that there and that. And notice there, I'm only considering one end of the member. Don't put your arrows in on both sides of the member, on one side only. Okay, I'm considering the right side of the. I'm going to consider forces on the right side of the cut line only. So I'm making my assumptions to the right of that cut line. If you put it on both sides, you will confuse yourself and get it wrong. Right, so that's compression, that's tension, and I'm going to say that CJ is in tension as well. Okay, right, let me see there. Okay. Right. So I am going to take moments about any point on the truss. Okay, considering forces to one side of the cut line only. Right, so we need to take moments about the point which is going to eliminate 2 and find the third one. So I'm going to take moments about J for the start. So I'm going to say the sum. So I'm going to say at joint J. Right, at joint J. Right, at joint J. I'm taking moments about this. So I'm considering forces to the right side of the cut there. So it's going to be plus 65. What's the lever arm for that one? It is 12 meters. Minus 73.33 minus 73.33 times, right, times 6. That's out of the equation. That's out of the equation. And that is in the equation. That will be plus because it's clockwise with respect to J. So it's plus CD. What's the lever arm? The lever arm for that force actually is the length of member JD, which is 7. Oh, that's an easy one. Are there any more? There's no more. Is equal to 0. Now remember the rules. Remember the rules. Take moments about any point on the truss, considering forces to the one side of the cut line only. Only consider the applied loads, the reactions, and the forces in the members themselves. I'm not concerned with JK, DK, DE, or I'm not concerned with those. Okay, right. So therefore, I'm gonna write it here. Ah, man, let me make it here. So I'm gonna say therefore CD is equal to, do the calculation yourself and check me out. And I got CD equal to, CD was equal to, very important, minus 48.57 minus 48.57. What does the minus sign mean? The minus sign means that CD is not in tension, it is actually in compression. So I'm going to change it. Okay, so it's actually doing that, and it's doing that. And I put both arrows in to tell myself I'm done with that one. So it is in compression. Okay, if you got that right like that, good start. Right. I need to take moments about another point to determine either HJ or CD. I'm going to take moments about D. So I'm saying at joint D. People, you can take the joints in any order. You can take moments where you want to, but I'm just happy to take it there. Okay, so if I take moments about D, is that going to be right? No, it's not going to be right. That's a bad choice. Why? Because CJ and HJ will be unknowns in my equation, so that's wrong. I shouldn't have taken that. I'm gonna take joint C rather. Yeah, that's a better one. Well, I'm taking moments about joint C, so that's out. I can determine HJ. So I'm taking moments about C, considering forces to the right side of the equation there. Right, so let's see about C. That's going to be, HJ is going to be positive. So it's HJ multiplied by, now the lever arm for HJ is the length of member HC, which is 7 meters. So 7, right, plus 65. Because 65 is clockwise with respect to C, plus 65 times the whole there, which is 18. Minus VE times 12, which is 73.33 times 12. There's no more, so it's equal to 0. Okay, so therefore HJ is one unknown in one equation. I can now solve for it. Okay, stop the video there, do the calculation, and check if mine is the same as yours. And you should have gotten minus 41.43 kilonewtons. Okay. And what does the minus sign mean? The minus sign means that HJ is not in compression, it is actually in tension. So I'm going to take it out and change it. So it is in tension as well. This truss is giving me a hard time. I made incorrect assumptions. Just by the way, why is that all in tension? It's because this whole frame is cantilevering about there. So it's actually, if I could draw it in as a beam, it's actually doing that about here. So there's tension along the top there. Okay, that is why the members are in tension. They're being stretched. Okay, let me take them all out again before it confuses you and myself. Okay, right, so that's in tension. So HJ is also in tension. Are we done? No, we need to still find member CJ. So what we're going to do, we're going to take moments about a point which will help us to determine HJ. I can't take moments about there, I can't take moments about there, but I can take moments about H, or I can take moments about D to find CJ. Okay, right, so let's do that over there. I'm going to take moments about D. Right, I'm going to take moments about D. So I'm going to say at joint D, at joint D. Taking moments about there. So what's the rules? Take moments about any point on the truss, considering forces to one side of the cut side only, of the cut line. Here's my, okay, so I'm taking moments about D. That's in the equation, that's in the equation. CD is out, but notice here, I cannot determine that, and HJ needs to come into the equation too. Be very careful. A lot of students come here, they say, no, HJ is done, I can forget about it. No, you can't. Okay, right, I'm taking moments about D. Right, so I'm doing the pluses first. Doesn't matter the order, just take all of them. So it's plus 73.33 times 12 minus VE. That's nonsense, ne? That is not correct. Let me just, I got the wrong one there. Silly me. Let me start again. Right, it's plus 65. Plus 65 times 12 minus 73.33, and that's a bit better, isn't it? Minus 73.33 times 6, because it's clockwise with respect to D. Right, that force there, okay, remember I'm considering forces to the right side of the cut section. That will be anti-clockwise with respect to D, so it's minus, and what's D? D is, that's force HJ, so it's 41.43. What's the leave arm for that force there from D? It is the length of member JD, which is 7, so it is 7 meters. And then this force here, okay, now remember that force about this point, this force will be anti-clockwise, so it's minus CJ times. Okay, and how do I find CJ? Now, let me just do this quickly. Right, what's the definition of a moment? A moment is a force multiplied by a perpendicular distance. There's the line of action of force CJ. So if I draw a line from D at right angles to that line there, there's my right angle there, and that little distance there, okay, will be the lever arm for force JC. So the member, so the moment of force JC or CJ multiplied by the perpendicular distance through D will be the moment of that force. Okay, so can we work out distance CD, that little d there? Of course we can, but we first need to know that angle there. Can we work at it? Of course we can, because we know our trigonometry so well. I have a side there, I have a side here. Work at either that angle, work at that angle inside there, and then using that angle and that side, 7 meters, find little d, and that will be the moment of that, and then we'll be able to solve for CJ and determine CJ. Okay, so you work at that, do the trigonometry, and then you check me out. Right, if you've done the maths, trigonometry, you find there, just as a check, that little angle inside there is 40.60 degrees. And using that angle and that side there, little d, I'll write it there, little d is equal to, I got as 4.56 meters. Okay, 4.56 meters. Okay, so that's the lever arm for force CJ. So CJ times 4.56 is equal to 0. Right. So we have everything, we got all the bits there. So do the calculation and check my calculation against your one. Right. And what did you get? You should have gotten CJ as 10.97. So therefore CJ is equal to 10.97 kilonewtons. And yippee! This time I got a positive answer. So my guess in the beginning wasn't too bad actually, and because it's positive, it means that CJ is in fact a tension member, as I so correctly guesstimated at the beginning of it. Okay, so people, as I was saying, there's the procedure again. I worked to this procedure, I worked to that whole procedure 3 times, once for each of the members there. Okay, so HJ is 41.43 kilonewtons, it's in tension. CD is 48.57 kilonewtons, it's a compression member. And CJ is 10.97 kilonewtons, it's a tension member. Okay, so people, if you done the frame last year, and if you go back to your notes there, you can actually check that frame against all of that over there. And then I think I will actually just give you all the answers for that one, so you can go if you want to. Well, not want to, you should actually go ahead and complete it. Okay, so for example, if I want to find JK and DK and DE, I take a cut through there. If I want to find KF and EF, cut through there like so. If I want to find members KF and KE, I will take a cut through there. If I wanted to find members GA, GB and BC, I will take a cut through there, and so on, and so on, and so on. And you follow exactly the same procedure. You assume tension or compression to one side of the cut. Then you take moments, but any point on the truss considering forces to one side of the cut line only. Normally consider forces to the smaller side, smaller meaning that we have less forces to consider. You only consider applied loads, you only consider reactions, and you only consider the forces in the members. And when you take members about your points, always take forces. For example, when over here, I first took forces about J to eliminate those two to find that one. Then I took moments about here to eliminate that two to find this one. And then I took moments either about D or about H, but I chose D to find that one there because now I know the other two. And if you take moments about point D, for example, that's out of the question. I can determine this one, but HJ must still come into your equation. If you leave it out, that answer there is going to be wrong. Okay, so people there, so all the frames I gave you to determine for in method of joints, you take the same exercise, you take the same procedure for method of sections, and you go back to your frames for that I gave you in your method of joints, and you work through this, and you determine them. You determine the forces in the frames, in those frames there under method of joints, and you do the procedure there, and you must get the same answers for what you got as in the method of joints. Okay, people, so that's the end of this lesson, for a lesson for method of sections. Let me see if I can give you the answers for this one here, then you can work out the answers for the rest of this frame. Okay, people, if I go back to frames, there we go. Okay, there's the rest of the answers for that. There was the reactions which I used. Okay, there's member H, there's member CD. I'll go back. CD 48.57. There we go. I got 6. Member CJ. Member CJ was 10.97. I just rounded off, so yeah, that's 11. And HJ, I got HJ to be 41.43. It is 41.4, which is fine. Okay, so people, there's the answers for that one. If you stop the video there, you can make a note of all. So if you go ahead and apply the method of sections to all the other rest of the members in the frame, that's the answers you should give. That's the size of the answer. That's 41.4 for kilonewtons. That's tension. The T stands for tension. The C stands for compression. Tension, compression, compression, tension. That's 0 there. Anybody know what it is? The 0 just means there that member HC is a redundant member. Okay. The force in there will be 0 kilonewtons or 0.0. It will be very, very small. It's actually negligible. It's a redundant member. It's got no load in it. Okay, so people, that's the answers for that frame over there. So continue with that frame. Take cuts through 2 or 3 unknowns at one time. Follow the procedure and see if you get the same answers. Okay, people, that's it for now, and I will see you in the next video.